Hello students, this video will justify one of the property of a parallelogram. So here we have a theorem which says the opposite sides and angles of a parallelogram are equal. So the statement says in a parallelogram the opposite sides and the opposite angles are equal. So let us try to prove this statement. For that we will need a parallelogram. Here I have a parallelogram ABCD. So what is given? ABCD, or we can take let us assume that ABCD is a parallelogram. So here we are going to justify or prove this statement. So what should we prove here? We have a parallelogram, and in this parallelogram what is to be proved? The opposite sides and the angles of a parallelogram are equal. So we are going to prove. So to prove that the opposite sides, what are the opposite sides? AB and DC are opposite sides, and another pair of opposite sides are BC and AD. We know that a parallelogram has two pairs of opposite sides. So AB and DC is one pair and BC and AD is another pair. So we have to prove that they are equal. And another thing which we have to prove is the opposite angles of a parallelogram are also equal. So again we have two pairs of opposite angles. Now if I take the vertex A, at vertex A I have an angle A. It is opposite to angle C. So we have to prove angle A is equal to angle C and angle B is equal to angle D. For this purpose, I make a construction. I join the vertices A and C and I get my diagonal AC. So for this, the construction which we will do is join A, C to get the diagonal AC. So to start with the proof, before I start, let me remind you about the alternate angles. What are alternate angles? When I have two lines which are parallel to each other and it is cut by a transversal, I get a Z shape. So I have a Z shape here. The angles formed at the corners of the Z shape. See, I have a corner here, the angle formed between that, and I have another corner here. So if I have a Z shape, I have a corner here where an angle is formed and another corner here where another angle is formed. These angles are equal. They are called alternate angles. So I will refer to my alternate angles to prove this statement. So first let me take two parallel lines. I have AB and DC parallel because it is mentioned that it is a parallelogram. So my opposite sides are parallel. AB is parallel to DC. This is the symbol used for parallel. I already mentioned it in the video where we discussed the properties of a quadrilateral. So AB is parallel to DC and it is cut by the transversal AC. So AC is the transversal. Now when AC is the transversal, if you look at the figure, I have AB here, DC here. A, B and D, C. So when AC is the transversal, my Z shape is in this way. So my alternate angles are these two angles. So what are these two angles? BAC and ACD. These two angles are equal because they are alternate angles. So BAC and ACD, the angles formed at the corner. So I have BA and AC is the transversal. So this angle and this angle is equal. It is called angle BAC and ACD. Therefore, angle BAC is equal to angle ACD. Again, I have another pair of parallel sides. AD is parallel to BC. So, I have AD parallel to BC and I have my transversal AC in this way. So, these two, there is a Z shape formed. So, the angles formed at the corners are these. So, what are they? Angle DAC is equal to angle ACB. So, these two angles are same because they are alternate angles. Now, this diagonal divides the quadrilateral into two triangles. So, this quadrilateral is divided into two triangles. So, let me write down the names of the two triangles. In triangle ABC and triangle ADC. So, I have two triangles. Let me check what are the same things which are available. What are the properties which are same in these two triangles. In these two triangles, I have a common side AC. So, one of my side is common. AC is common. And my alternate angles BAC and ACD. BAC is here and ACD is in the other triangle. So, BAC belongs to the first triangle and ACD belongs to the second triangle. So, this BAC comes from triangle ABC and ACD comes from triangle ADC. So, these two angles are same. And again, DAC. So, DAC is from my second triangle and ACB is from my first triangle. So, DAC is equal to angle ACB. Now, three properties are same. So, side, their angle. So angle, side, angle. Here I have an angle, side and angle. So, this is a side, this is an angle, this is an angle. This side is in between these two angles. So, according to ASA, in congruent triangles, we learned that when these three are same in two triangles, the two triangles are congruent. Triangle ABC is congruent to triangle ADC. When two triangles are congruent, let us check. This is a side. So, the angle opposite to them will be same. Now, AC is the side. The angle opposite to them in the first triangle, the angle opposite to AC in the first triangle is angle B. What are the conclusions? These are the conclusions we get from the since the two triangles are congruent. Now, triangle ABC is congruent to triangle ADC. From this, we can conclude that the angle opposite to equal sides are equal and the sides opposite to equal angles are equal. Now, let us first take AC. So, AC is a side. So, we can write the angle opposite to them are equal. So, in the first triangle, the angle opposite to AC is angle B and the angle opposite to AC in the second triangle is D. So, those two angles are equal. Angle B is equal to angle D. So, we proved one of our required property. Next, coming to the second thing which we have. These two are angles. So, the sides opposite to them will be equal. What are the two sides? let's check for the sides opposite to these two angles. So BAC is here. So BAC is this. The side opposite to that is BC. So the side opposite to BAC angle is BC. Let us check for the side opposite to ACD. So I have ACD here. So this is ACD. So this angle is ACD. So the side opposite to ACD is AD. We checked the side opposite to BAC is BC and the side opposite to ACD is AD. Therefore, BC is equal to AD. So from the second statement, we got this. From side, we got the angles are same. From the angle, we got sides are same. Now I have another angle. So from that, we will get another pair of sides. So what is that? So what is the first angle? DAC. So DAC is this angle. Correct? So the side opposite to DAC is DC. So from here, from DAC, the side opposite to that is DC. Let me check what is the side opposite to ACB. So I have ACB here. So the side opposite to ACB is, you have to look at the side which faces that angle. So in this triangle. So the side which faces this angle is AB. So AB is the side opposite to angle ACB. AB. Now angle B is equal to angle D is proved. BC is equal to AD. We proved this, and we proved DC is equal to AB. We proved this. Now to prove this, we will have to take the other diagonal, because to prove angle B is equal to angle D, we joined AC. So angle B and angle D were there as a whole, but when we joined AC, we have angle B and angle D fully. We didn't have angle A and angle C fully in these two triangles. When we compare these two triangles, we have only angle B and angle D fully. So to prove angle A is equal to angle C, we will need angle A and angle C as a whole in the two triangles. To prove angle A is equal to angle C, so I have angle C here, I need angle A and angle C fully. So now instead of joining AC, I will join my diagonal BD, the second diagonal. To prove angle B is equal to angle D, I joined AC. To prove angle B is equal to angle D, to prove angle A is equal to angle C, I will join the diagonal BD. So now let me take AB is parallel to DC. AB is parallel to DC. Here, in last time AC was the transversal. Here BD is the transversal. So BD is the transversal. Now let us check for the alternate angle. So I have a Z shape like this. So this angle and this angle falls in between the Z shape. AB is parallel to DC. So I have A, B, D, C and BD is the transversal. So these two are my angles now. Angle ABD is equal to BDC. ABD is equal to angle BDC. So I write on that. Again, I have another pair of parallel sides, AD and BC. So I have AD and BC and the transversal BD. So I have a Z shape. So the alternate angles are these two. So let me write down ADB angle ADB is equal to angle DBC. So angle DBC. So these two are equal because they are alternate angles. Now let us compare these two triangles. Now I have triangle ABD and triangle BCD. So in triangle ABD and triangle BCD, if you see these two triangles, the side BD is common. So I have BD is common here. Next, what are the other two things which is same, so that I can prove these two triangles are congruent? Now I have these two angles. Angle ABD is here. So I have angle ABD here and angle BDC. BDC is here. So these two angles are same in these two triangles. So I'm writing it down. Angle ABD is equal to angle BDC, and the other two, ADB is here and DBC is here. These two are equal. Therefore, my two triangles are congruent because three properties are same. Again, the angle and the side in two angles and the side included between them. So, triangle ABD is congruent to triangle BCD. Now, from the property of congruency, I can conclude few things. Since my side is common, the angle opposite to them will be common. Now since BD is common to both the triangles, the angle opposite to them will be equal. So from the side, I can say that the angles opposite to them will be equal. So what is the angle opposite to BD in the first triangle? This is BD and the angle opposite to that is angle A. And again in the second triangle, BD is the same side is common. So BD, the angle opposite to BD is angle C. So from the first diagonal, I proved angle B is equal to angle D by taking AC as the transversal. By taking the diagonal BD as the transversal, I proved angle A is equal to angle C. So all these three were proved by taking AC as the transversal, and I proved angle A is equal to angle C by taking BD as the transversal. Now opposite sides are equal and opposite angles are equal. Opposite sides are equal and opposite angles are equal is proved by taking AC as the transversal first and BD as the transversal in the second place. Thank you.